Mechanism of micelle formation. When soap is added to water, micelle ions are formed. Let us see how. Mechanism of micelle formation. So soap when added to water we are saying. So what is this soap? Soap is sodium, potassium, salts of fatty acid. What is this fatty acid? Fatty acids are nothing but long straight chain. Long straight chain of carboxylic acid. These are represented as RCOO minus Na plus. Let us take one example of this. Example, we shall take it as sodium stearate. Sodium stearate. The composition is CH3, CH2 taken 16, COO minus Na plus. So this is added in water. After adding in water, what happens? See, let us draw the branch of this molecule. CH3, CH2 16 we have. So and here we have C double bond O minus and Na plus. So at the each end we have CH2 group here. So let us write everywhere CH2. So after adding this in water, what happens? This dissociates. The R in this, the alkyl group in this dissociates, and later what happens? See, all this part is ROO minus, RCOO minus dissociates, and this RCOO minus is having two parts. One is water loving, that is, it is attracted towards the water, and other one is water repelling. So all this part, the whole from CH3 up till this chain, all this is nothing but hydrophobic, water repelling. So this is nothing but water repelling. And this part COO minus is nothing but water loving. This is also called as, can be called as hydrophobic. Other class we have studied lyophobic. Here water is the solvent, so we are going to call it as hydrophobic. And this we can call it as hydrophilic. As hydrophilic. I can also also call this as non-polar tail, and this as polar ionic head. What happens now? If it is added in the water, we have learned that RCO minus is going to be having two parts. So in the water, the one which is hydrophobic is all in the water because it is water loving, it is attracted towards the water. So all the polar ionic head, hydrophilic, all hydrophilic ends, it is inside the water, whereas all the hydrophobic ends called as non-polar tails are all above the surface of the water because they are repellent of water, they want to stay away from the water. After some times what happens when the concentration increases, as concentration increases, all these molecules are pulled inside and form a sphere. The sphere in such a way that all the COO minus is above and all the non-polar heads are inside and they form an ion. These ions are about 100 micelles together. So this way they are forming a micelle ion. There is a sphere in it. Later we are going to study how this process works. Next we are going to study cleansing action of soap. Next we shall study cleansing action of soap. If there is any grease on the cloth, how it is cleaned is, the grease is water repelling. So your two parts are there and this RCO minus. One is hydrophobic and other one is hydrophilic. In the water, when a cloth is put, suppose we have a cloth here and there is one oil drop on this cloth. Your micelle ions are formed. What happens here is, all these hydrophobic ends are above the surface of water at a certain concentration called as critical micelle concentration. At critical micelle concentration, all these ions aggregate together and form an ion. So all these hydrophobic ends are pulled inside, they are attracted inside towards the oil droplets and all the COO minus charge is above this oil drop. At what concentration? At critical micelle concentration. All the hydrophobic ends enter into the oil drop and all the COO minus, which is hydrophobic, is above. Later, because these COO minus are hydrophobic, these are attracted towards the water. When these are attracted towards the water, these pull the oil droplet above and this way the oil droplet is removed from the cloth. Next, what we are going to study is preparation of colloids. First one is we are going to take arsenic trioxide and treat it with hydrogen sulfide. Here double decomposition occur. What happens here? Arsenic splits into As plus 3, here oxygen into minus 2, here H plus and sulfur as minus 2. Later these plus and minus combine and form sol of arsenic sulfide. As2S3 sol is formed and water is given out. H2O3. Okay. Next one we shall see now. Sulfur dioxide is taken and then treated with hydrogen sulfide. What happens here? This sulfur dioxide is having oxidation state plus 4. This sulfur is having oxidation state minus 2 plus 1 minus 2. Here sulfur sol is formed and then H2 is given out. If we take a number line, we are going to see oxidation reduction, how it is occurring in this. If the number line is like this, increasing number this side and decreasing number the other side. Oxidation state of the sulfur dioxide is plus 4. So plus 4 is becoming a 0 here. If it is becoming 0, the number is decreasing. When the number is decreasing, we say reduction is occurring. And here minus 2 is becoming 0. The oxidation state is 0. So minus 2 is becoming 0. So number is increasing. So we can say oxidation is occurring. This is an example of proportionation reaction. Proportionation reaction. One more we have an example. If we take gold chloride, if we take AuCl3 and combine with formaldehyde and then water is added to it, let us balance that one. And next what happens here? Here reduction occur. So all this splits into Au plus 3Cl minus and here H plus and then OH, O minus 2 plus and minus combine. Gold sol is formed here. So I'll write here gold sol and then HNCl is present reactant side, so HCl will be formed and the other compound what is remaining, oxygen will be remaining. If HNCl is combining, what remains is oxygen. It goes and combines with formaldehyde to form formic acid. HCOOH is formed. That is right here. Formaldehyde and here formic acid. Let us balance the equation. 3Cl we have. So if I write here 3, six HCl and then here 2 gold sol. One more example is given in NCERT. It is ferric chloride. When ferric chloride is treated with water. It undergoes hydrolysis to form the soul of ferric hydroxide, and then what happens here? Fe splits into Fe3 plus, here Cl minus, here H plus, and here O minus 2. Plus and minus combine here. So HCl is formed. So this is an example of preparation of colloids by chemical method. After this, we are going to move on to the next method called as Briggs arc method. The second method is Briggs arc method. Also called as electrical disintegration. Here both the things occur. Dispersion and condensation, both the things are occurring here. For this, we can prepare the gold soul like gold soul, platinum, silver, such kind of souls are prepared. For this we require a container. A container is taken and ice is placed in it to form the ice bath. So, in a container, we have kept some ice called as ice bath. On this ice bath, we are going to place one more container. This container is having a dispersion medium. And a little potassium hydroxide to stabilize. If I want to prepare gold soul, I require an electrode made up of gold. This is having some impurity. This metal is to be converted into soul now. So these two electrodes are kept, which is connected to a battery. So these are electrodes. What is done here is high arc is passed here. Due to this high arc, there is an increase in temperature. The warmth, what it does is it vaporizes some metal from this. After vaporization, the vapor get condenses due to this ice bath, and then they convert into the colloidal size particle. So this Briggs arc method is useful to prepare gold soul, silver soul or platinum soul. One more method we have for preparation of colloids. It is peptidization. In peptidization, what happens? The precipitate is converted into colloidal soul. Let us take one example of precipitate. Some NaCl I have taken and added water in that. It became an electrolyte. That electrolyte, if I add AgNO3, it converts into precipitate. That precipitate has to be converted into colloidal soul. For that, I have to add some amount of electrolyte. By adding some amount of electrolyte and shaking, what happens is the ions of the electrolyte go and adsorb on the precipitate, and due to this, the precipitate molecules break down into colloidal soul. So what is peptidization? It is nothing but, let us take the conversion of precipitate into colloidal particles by addition of small amount of electrolyte. What happens here is the ion of electrolyte adsorb on the precipitate and it get charge either positive or negative charge and breaks into colloidal particle. You can also take down about this. An arc is struck between the electrode due to which the metal evaporates and then get condensed and then condensation occur due to which the colloidal particles are formed. So there are three methods of preparation of colloids. Next we shall move for purification. Next we shall learn purification of this colloidal solution. First one is dialysis. During preparation of colloidal solution, there will be some soluble substance present in the solution. To remove that and get only colloidal particles, we are going to do an experiment called as dialysis. For that, what we require is a container which is having continuous inward and outward flow of water. In this water, pure water, we are going to place a bag. That bag is made up of parchment paper. In this, there is a colloidal salt which is having an impurity called as crystalloid. And there are also some salt particles. We want only salt particle and we want to remove this crystalloid. You can take an example. Parchment paper bag is there. In that a tea solution is there. Only tea solution, decoction is there, and there are some colloidal particles. This tea is acting as a colloidal particle. Along with that, if we add salt in that, what happens is salt is a crystalloid here. We need to remove the salt from that parchment paper bag. We have to just keep it for a long time After keeping on to the long time, the crystalloids, the salt particle will move on to the solvent in the water and it is let out. Continuous there is flow of water, because of that always we are getting pure water in the container, and all the salt particles are removed, crystalloids are removed after some time, and what remains is only salt particle. This method is very slow. To make this method faster, one more method is carried out called as electrodialysis. Electrodialysis is nothing but to the same dialysis method we are going to introduce two electrodes. Here two electrodes are kept. Because of two electrodes, the ions present in the colloidal soul as an impurity. Here usually this is done only when an impurity is an electrolyte. If an impurity is an electrolyte, this process is carried out. And also we have soul particle. This is a parchment bag. Here always there is an flow of water. Because of this, we get pure water for the experiment to carry on faster. After this, we have one more method called as ultrafiltration. Ultrafiltration is nothing but here the colloidal particles are filtered and separate, the impurities are separated. We cannot make it by our common filter paper. This filter paper is to be converted into ultra filter paper. This can be done if we add this filter paper in the colloidal solution for a longer period and dried by the formaldehyde. So colloidal is nothing but colloidal solution is nothing but 4% nitrocellulose. And alcohol and ether, and later added in formaldehyde solution to harden. So what is done here? Filter paper is produced, ultra filter paper. That filter paper is produced by dipping the filter paper into the colloidal solution for a longer period and then added in one more solution called as formaldehyde. Why we are adding formaldehyde? So that the filter paper hardens. Whatever residue we are getting in that parchment paper, that is again added in the dispersion medium to make the colloidal soap.